All right, so this question reads, exactly 8 computer processor chips, F, G, H, J, K, L, M, and O, are ranked according to their speed from first fastest to 8th slowest. The ranking must be consistent with the following. Okay, so we have our inventory. We have F, G, H, J, K, L, and M. We have first through 8th. 1, 2, 3, 4, 5, 6, 7, 8. First being the fastest, and 8th being the slowest. Now, let's look at the rules. Rule number 1 tells us that there are no ties, so that just tells us that there's going to be a 1-to-1-to-1-to-1 ratio. Rule number 2, either F or G is ranked first. So rule number 2, we know if F is not ranked first, then G is ranked first. And if G is not ranked first, then F is ranked first. So either F or G is first. Rule number 3, M is not the slowest. So that means M is not 8th. So M, not 8th. Rule number 4, H is faster than J with exactly 1 chip intermediate in speed between them. So we have H faster than J, but there's 1 intermediate chip between them. And so this is a block, meaning J has 2 chips before it. So J can't be second or third, because if J was third, we would technically have our intermediate chip, but then where would H go? Likewise, if J was second, there would be no place for our intermediate chip or for H. Similarly, H can't be 8th and H can't be 7th because there needs to be room for the intermediate chip and J. So, rule number 5. K is faster than L with exactly 2 chips intermediate in speed between them. So we have K, 2 chips, and then L, and this is a block. So that means L has 3 chips in front of it. So L can't be second, third, or fourth. Likewise, K has 3 chips after it, so K can't be 8th, 7th, or 6th. Now, rule number 6. O is slower than both J and L. We have J, L, and then O. So that means O can't be second, and O can't be third because it has J and L in front of it, and that means J can't be 8th and L can't be 8th. Now we can go further on this and say, since O is after J and L, we can add on to rule 4 and say L is somewhere here. We don't know where L is in relation to J, but then O is after both. Similarly with rule number 5, we can say J is somewhere here. We don't know its relation to L, but we know that O is going to be after it. So that means that at the least, O is going to have 1, 2, 3, 4 chips in front of it, because remember, J could possibly just be one of these intermediate chips. So we can deduce that O now can't be 4th or 5th. So the earliest O could come in is 6th, because then that would give room for our L, our 2 intermediate chips, and then K, and then hopefully J is somewhere in the intermediate chips. Now, since J and L no longer can be 8th, that means that K can no longer be 5th, because if K were 5th, then we would need L to be 8th, and now L can't be 8th because O is after it. Likewise, H can't be 6th, because if H were 6th, then J would have to be 8th, and J has O after it. So that means that the only 3 chips that could be last are F, G, or O. Okay, so that's all the deductions we can make following the rules in the setup. Let's go ahead and hit the questions.